I have seen your observability future. You can choose a better one. This is Monitory Report. I'm Ian Bennett. I'm a software engineer on Twitter's observability team. You can follow me at ENBNT. It's great to be back at Monitorama. Kind of. It was an honor to be slotted in the opening spot for the conference, but life happens. I'm really sorry that I couldn't be there with everyone for the conference, but I'm glad that I still have the chance to share this talk with you all. I'm here today to take a look at some of Twitter observability and Monitorama history and maybe share some insights that could put you on a path to a better future. So, what is Twitter? Twitter is what's happening. Twitter is seeing every side of the conversation. It's where people share some major news and announcements with the world or just a few friends. Just a few days ago, I got married. I love you, Kim. Let's talk about what role our observability team plays in the Tweets Factory. We help make Twitter infrastructure observable. Twitter infrastructure has roughly 12,000 services that comprise 6 million service instances that generate 4.8 billion metric writes per minute. We primarily use these technologies, which we consider the Twitter stack, which uses Apache Mesos and Aurora, Java and Scala, we're very heavily based on the JVM, and Finagle and Finatra, which are Twitter open source frameworks that you can use. We use other technologies, but these are the primary ones. So if you're thinking of starting an observability team, you should ask yourself this question. What is your company's mission? Is it observability, metrics, tracing, query language design, storage backends, data analytics, data visualization? If you answered no, be prepared to wear all of those hats. Be prepared to market and lobby. Understand what you're enabling. Understand your vision. Know what value you are bringing, and be prepared to continue to sell that. Our observability team is not Twitter's mission. So then what is your role? Your role is to build a culture of observability. This means giving your users metrics, logging, and tracing automatically. You need to help improve understanding of systems. That means making and discovering your systems easy. It also means making it easier for users to understand their systems. Recognize that people are important. You have a role to play in the quality of life of the people around you. So that means that you need to build empathy into your products. The time that they're going to be used the most will be under high stress, high pressure situations. You want to remove as much of that burden as possible and get people out of your tools as much as possible. So that you might have to do things like be available for support, ensure your systems are up and running and stable with on-call rotations and learning from your customers' mistakes and more. So then Twitter's observability stack is made up of the three pillars of observability, which are metrics, logs, and traces. For metrics, we deal with Cuckoo Query Language, which is our own internal time series database and query language. We have Viz dashboards in our Monitoring 2.0 stack. LogLens is for distributed log collection and analysis, and Zipkin is our distributed tracing infrastructure. Your stack may look similar. You may also have a spot for other analytics debugging tools supplementary to these, but we're not really going to dive on those here. We're going to focus on metrics and monitoring. By making your systems observable, you are building a platform. Observability is a platform. So by doing that, you can enable things like automated canary analysis. See Megan's talk on Tuesday. Automated performance optimization, automated performance verification, automated host and service remediation, anomaly detection, and chargeback, which Twitter uses internally to track how much money different services are spending on other services. This is a quick high-level overview of our metrics architecture. One of the key pieces here is that our read and write paths are separated from each other. I'm not really going to go in depth here, as these have been covered as part of previous Twitter engineering posts by the observability team, as well as previous talks at Monitorama. Feel free to reach out for links on more documentation here. And then this is our monitoring architecture, where we have our UI layer, which is MonViz, our API layer, which involves dashboard management, monitor state, monitor history, monitor snooze status, our query language interface. Our business layer includes configuration management, which gets stored into MySQL, Monalert, which is our periodic running alerting system, pulls data from the configs and also queries against Cuckoo. It stores monitor state things in Manhattan, which is Twitter's distributed key value store. Cuckoo is used and runs against our time series database, which is based off of Facebook's Gorilla paper. Note that this is a newly productionized service, and it's shown some tremendous improvements in our systems. It also runs in Mesos and Aurora and is designed to be fault tolerant in a cloud setting. So I'm going to share a brief and incomplete history of some observability tools, mainly in reference to Twitter Stack. I might make reference to a few of these dates as we go on, so just be aware of that. 1999, Nagios was released and introduced to the world, so clusters could now be managed. In 2010, Twitter starts work on its own time series database and query language, Cuckoo. In 2011, Twitter creates Zipkin and shares it as an open source project. It also starts work on KoalaBird, a monitoring and alerting system that leverages Cuckoo. This system is retired in 2017, and we're going to talk quite a bit about that process as part of this talk. In 2013, InfluxDB is shared as an open source project. That is not a Twitter project. Same for Prometheus, which was shared as an open source project in 2014. Keep in mind some of these dates: Cuckoo 2010, InfluxDB 2013, Prometheus 2014, as they'll play a role in some of what we discuss later. In 2014, Twitter also starts work on its next generation monitoring system, Mon 2.0. A presentation on the system is given at Monitorama 2016. So let's assume that you're observed and your systems are up and running for a few years. You've seen growth and hit some problems with your current setup. You've made the decision that the right thing to do is migrate to a new system. For some of you, this may be one of your potential futures. For Twitter, this means actually looking back in the past. So let's do that. In Q4 of 2014, the decision was made to invest in a replacement for Twitter's older alerting system, KoalaBird. Work was started on a new system. In Q2 of 2016, 80% of the migration was completed to the new system. At Monitorama 2016, Megan, Justin, and Dan gave a presentation on Twitter's next-gen alerting system. If you haven't watched it, please do. For one, there's such a great history of the Monitorama conference available online. For the other, there's way more detail in that presentation than I can touch on here. This is also around the time that my journey at Twitter begins. I joined Twitter in July of 2016, and I was brought into the observability team as a more senior member looked upon to help guide this migration to its completion. So in Q4 of 2017, all of Twitter was 100% migrated to the new system, and the old system was shut down. Before we dive into what took so long, let's take a look at some of the things that we gained. Some highlights. 1, alerts and dashboards. There's now one place to configure and share that information. There's one place to view the state of your system. 2 is ensured evaluation. New system was more resilient to instances going down temporarily. It also has the ability to look back and alert if there was an outage. 3 is cross-zone fault tolerance. The new system isn't tied to a specific zone, region, or data center. The alerting system can go down completely in a zone and still function. 4 is improved operability. The new system runs in Mesos and Aurora. It's a much better toolchain and ease of deployment compared to the old system, which was run in bare metal. The new system was designed to be resilient, where the old had made some assumptions. 5 is clearer alert behavior. There was a removal of the custom domain-specific language for the older alerting system that was used for defining alerts, and it wasn't very clear as to how things were supposed to execute. The new system clearly defines those and gives clear expectations compared to the previous system. Another few things to touch on is that we actually reduced the dashboard and alert query times by 50% by moving to the new system. The new system is much more efficient at how it deals with querying data compared to the old one. We also introduced our new time series database shortly after decommissioning the old alerting system, which resulted in another greater than 50% reduction on query times on top of that. Our users like fast loading dashboards. I'm sure yours do too. They were very happy with this. And lastly, there was now one monitoring system. A major benefit for us as the observability team and to our users was that there was only one system to understand and work with. There wasn't two systems that needed to be maintained and operated simultaneously. So let's look at that 80%. We hit that 80% pretty quickly, and the last 20 took a while. What went wrong? Why did it take so long? And will the same thing happen to you? We saw that these 5 things really impacted our migration. So let's take a look at these 5 topics and how they relate to each other. We're also going to touch on some of the things that we have done or are doing to make them better. So the first is the query language. In order to create or maintain alerts and dashboards, you need to be familiar with the query language associated with the monitors. So this is Cuckoo query language, CQL for short, as seen in Twitter engineering blogs. These 6 queries here have very different behaviors. Don't worry, there's not going to be a quiz. This is just to illustrate a point. So this first query returns a pre-aggregated time series for the overall service. For example, the sum or average count of requests for a specific metric. The second query returns a time series for instance 0 of the service. This third query returns a time series for every instance that is a member of the service using our temporal index lookup, which means that it knows what instances exist over the span of the query time range. This next one returns a time series for every instance that is currently a member of the service. This uses a different indexing system that is only a live snapshot. This query returns a time series for every instance that matches the service ID pattern. This uses the temporal index lookup that our members query used. Are you getting confused yet? All right, and this is the last one. This one returns a time series for every instance that is currently a member of the service, but the metric ID matches the given pattern using the temporal index. So the membership and query lookup here are actually using different indexing mechanisms, and there's an impedance mismatch. So this results in users defining alerts and getting odd behavior that they don't understand. This represents an aggregate by failure type metric. For instance, if you wanted to see the exception type being thrown across the instances of your service, this would be a way to go about doing that. And this one returns the overall success rate aggregate for a service. So success over success plus failure. We've got other things like defaults to fill in if there were missing values. And a note in the previous query and this query is that when querying its zone data, you'll actually get back a time series for each of the zones, at least. So bird law, it's not governed by reason. Do not write your own query language, please. If you ignore that warning, have a well-defined spec, document guidance on the direction and intent of the language, have a direction and intent for the language, be deliberate about adding new language features, be aware of the impact your design decisions will have on your end users. Also realize that distributed systems problems are lurking behind every corner. Remember, Cuckoo was created in 2010 and is still in use. At the time, there weren't the options that exist today available to Twitter. We still have advantages, and there's a reason that we're still on Cuckoo. Some of those are cost and scale. Also, the language is powerful, but all of these things come at a price. As an end user, it can take years to become an expert. That can't be acceptable when your purpose is to enable engineers today. One of the things that we're working on is simplifying the query language in our service stack. Doing this has a ripple effect. It means the concepts are clearer, and you'll spend less time explaining or debugging disparities in support of our end users. Now that we've touched on the query language, the next step in monitoring is to configure dashboards and alerts. Let's talk about it. When choosing to use code as config, you actually have some choices to make. You choose these things. How do you choose what language or languages to support? How do you integrate with your query language? Do your teams use different programming languages? What one does the config belong in? Does it belong in all of them? Do you need to support every function and behavior of the query language in the config, or are people left to edit things as text or strings? Are all of your customers coders? Do you want to allow data analysts, non-technical managers, stakeholders to be able to understand or use your systems? Where is your source of truth? Is this your source repository where you require code review? Or is this a database, or is this something else? You have other choices to make. What is your config updating process? Does that require code review? Is that landing in the repository? Is that through the API? How does this change if your users are in an incident? Does that mean that if they wake up at 4 a.m, they have to submit a code review in order to get some thresholds changed? Do you want to support UI or API config changes? And if you do, how do these changes make it back into code? Do you need to write code that will take your domain-specific language and turn it back into code? Are you losing any extra information as part of that process? And how much extra effort is all of this? Do you have common shared libraries? Who owns those libraries? Is it your team? Is it the end users? What are your customers building on top of those shared libraries? Do you actually know how your customers are using your product and what they're doing with it? Because you probably don't. And do you ever plan to add new features that might require breaking changes or moving to a new version of the config? What is the process to move all of those over? Is that another migration? You chose poorly. So at Twitter, we went from having a separate monitoring config repo where configuration was a custom Ruby DSL to sharing configs in our mono repo, where configuration was managed with Python. The Python configs would include templating and structure, and then be flattened to JSON and uploaded to our API by way of a command line tool that our team provides. So we solved the problem of users having to deal with Ruby, but we created the problem of users having to deal with Python. This also meant creating an API that wasn't. Some of our customers would use our APIs directly, but all of our workflows that we supported were expected to be code as config. So most of the customers actually expected things and wanted things as code, but most isn't all. So now we own managing both of those. If you choose this, I hope you enjoy doing twice as much work. What this means is a manual migration. If your source of truth is config, you cannot migrate your customers between configs. Your customers own the configs. Your customers own the migration. Is your customer's job managing configs? Because if it isn't, then that's probably going to introduce some problems. However, if you run an API, you own the data. You can own the migration. As an observability team, it is your job to own the whole solution. So what are we doing to improve this? We're moving towards an API-driven approach. Our UI supports a query playground with code completion for our query language. Our common libraries are becoming first-class API features. So this doesn't mean that users can't create configs programmatically. It just means that our API is the interface that we're giving them instead of shared code libraries. And we would actually encourage people that need to do things programmatically. That's fine. So after we've got through query and config, we also ran into the problem of incompatible concepts between the two alerting systems. Different systems may have different features. This is especially true if you're changing query languages. Luckily at Twitter, we're sticking with Cuckoo. However, monitoring definitions are a close second to that because they're so tied to the query language and they're so tied to the feature set that they have. So this means that you need to be more careful during the migration. This means you need customer interaction to make sure things haven't broken and that things are correct because this is a mission critical piece of infrastructure. So this means a slow manual migration. This concept of one versus many is one of the bigger problems that we had. So our legacy alerting system, KoalaBird, was based on a single query being executed for each source. So each instance of a service would have its own query executed. Our next-gen system, MonAlert, was based on a single query being executed for all sources. So all of the instances would come back in a query. For simple alerts, this isn't really a problem. You can just apply a predicate against each of the sources that come back, and you can easily convert between these two concepts using the same query language, no problem. So 80% of our alerts followed this simple query and predicate pattern. These alerts could be easily converted without much intervention. We would just give our customers a script to run, they'd get the new configs, and they could be on their way. However, there was a missing feature between the two systems, and we call this aggregate monitors. So what does this mean? It means that you can determine a monitor state based on aggregate results. Why do we need this? Why couldn't we just say, no, you don't get this feature? Well, one, it helps to reduce noisy alerts. You can do things like, don't page me if traffic is low and the success rate is dropped in the middle of the night. You can also prevent thrashing from automated remediation. Say only restart an instance if it's been up for a few minutes. Some of the features that were part of the old system are being able to do things like and or results together. A single time series query that returns many results is a simple-ish concept. However, being able to aggregate results on a matrix of varying dimensions is not so simple-ish. Ands and ors aren't really enough, and we're going to talk about why the multidimensionality complicates things here. So let's look at this and. We've got two time series queries. We've got query 1 and query 2 that each return some results. Just saying that we're anding them is actually kind of ambiguous. Do you want to know if something from each child query has gone wrong, or are you looking for a more detailed state of a single instance? To further complicate things, some time series don't actually have a source if you want to aggregate on them, because they themselves are an aggregate across instances. So we need to be flexible. We need to support anding across queries and anding on different dimensions. So we came up with and on source. This means that the source is the dimension that we're anding on across the queries that are given. So here you'd see source 0 has a query 1 and query 2 result, and that's what we're looking at. This was the missing feature between the two alerting systems because of the difference in how they behaved. We actually spent months iterating on how to expose these missing features to our end users. We even had a nearly complete solution that we ended up scrapping because it was complicated for users to understand what the results were coming back from it and how their alerts were behaving. So while the end result that we have here isn't perfect, it's not a simple problem, so there are trade-offs. The best we could do here is to support these features by creating well-drafted documentation and diagrams with example usages. It's sort of what I'm showing you right here. So there's a general problem. There's a problem with monitors. Monitor definitions are essentially vendor lock-in for your alerting system, and they're also pretty tightly tied to the query language that you're using. They live longer than your time series data, but they change less frequently. It's really easy to forget the high cost of entry to defining alerts. There's complexity and nuance to doing this, and that complexity and nuance was one of our highest observed pain points. Users won't be defining monitors every day, so that knowledge of working with the system isn't really actively retained. So what we're doing now is looking to simplify the vocabulary that we use across our different products to reduce that mental model and makes the concepts as transposable as possible. We're also driving towards removing boilerplate and giving people as much dashboard and alerts automatically defined out of the box, based on what we know about their services. This is something that can help differentiate us because we know what they're doing at Twitter. We want to remove as much of this burden on our end users as possible. Now that you have our query languages and concepts in hand, we leave it to our end users to define dashboards and monitors to be used. This might look like a user defines a monitor by creating queries and defining predicates against them. The user uploads the dashboards and alerts, and everything's done. Everything just works perfect. Except maybe they've made a huge mistake. How often do you think users define the wrong thresholds? And what is the cost of that mistake? Is it an incident for your company? How much money is lost? How long does it take you to find the mistake? Is it weeks? Also, there are some other parts of the story that don't really make a lot of sense. Do you even know what your notifications look like until you've entered an incident? Do you know what data you're given to help debug? What is the added stress to our end users by not giving them this information up front? The story here is generally terrible across the industry. This was a major pain point during our migration, and it made it more difficult for users to build trust in our systems. We're trying to make it easier for users to understand the behavior of their monitors and have ways to see what notifications are given outside of an incident. While the bare minimum should be thorough documentation, is there something better that we can do? We want to get to the point of having the ability to build and test alerts from the same UI that people are used to monitor and dynamically debug incidents. This will allow them to build trust and confidence in our systems and in their alerts. Users should be able to test notifications, be familiar with the tools and the data they're given to debug before it's of critical importance. With everything we've discussed so far, we now find ourselves at scope and the role it played in our migration. This was a ground-up rewrite of the alerting system, and it was also a ground-up rewrite of our front-end viz. This turned out being a much larger undertaking than expected, and the front end is still not completely replaced, so maybe saying that it was 100% migrated was a lie. But 100% of our alerts were, so it's not completely a lie. The lesson was scope. Migrations are hard. you really want to limit the scope of work that's done during them. You want to limit the scope of what you plan to migrate, and you want to limit the scope of user interaction. What we're doing here is we're trying to make changes to drive a simplified user experience and to reduce the complexity of the systems that we own. We're driving for more feature alignment in our work across the stack so that it doesn't take years before users see a benefit. I mentioned that part of your job is selling, the other part is delivering. Users will lose patience if they don't see their concerns met or features shipping. Some of these things aren't quick fixes, and there will always be unknowns that you can't account for. So it doesn't mean that you can always ship when you expect to. But that means hitting bumps along the way and continuing to adjust and iterate. So how does this apply to you? As you grow, your systems may not grow with you. How you handle the next step will come with trade-offs. Do you write a new system from scratch? If you do you plan to open source it? What does it mean to be open source ready? What is the cost of that open source investment? Also, what is the cost of keeping that thing closed source? Does that mean that your systems deteriorate over years? If you consume or modify an open source solution, is it easy to operate? Does it scale? Does it meet all or most of your needs? Who owns the project? What is the license? Is it well maintained? Will they even accept changes that you want to make back upstream? Do you pay a vendor? If you do, how much and how long is the contract? Can they support your needs and requirements? Will costs go up or down over time? What is the long-term viability of the company compared to your own? Who owns the data? And is there a migration path if things go sour? Or are you just going to be back at square one? While we can't make promises in open sourcing our entire observability stack, we would like to share with you our intent of open sourcing our evaluator project. This is a key building block for the future of our monitoring infrastructure, and the work we've put in is continue to open up new opportunities for us internally. Let's take a quick look at what we want to share with everyone and how it relates to some of what we've discussed. So the evaluator gives us an ad hoc evaluation API. We can send data in. It's flexible. You can plug in new data sources, which will help reduce things like vendor lock-in. And we can also supply custom time series data via the API to exercise things. So that opens up some possibilities. That means that we can treat the monitor as a shared primitive. This definition can be used and shared across different infrastructure tools so that users can reduce their cognitive load of complexity. It also means that we can run integration tests against the monitoring system and understand the behavior, which means that we can help our users build trust in our systems and also trust in ourselves. One thing that I didn't mention is that we would occasionally run into problems where unit tests all passed, but we didn't have the ability to run integration tests against the periodic alerting system. And that means that it might take weeks before our customer catches bugs that we couldn't. That's a problem. This means that we can also do alert building and testing, including testing notifications. It means potentially tighter feedback loops. You're outside of this periodically running system. It means flexible integration. This is now a building block that can be used to build other more complex functionalities on top of it. I had mentioned before the ability to build and test alerts in the UI. This is actually the work that's driving that. So let's do a demo. If you didn't catch everything during the demo, how could you? All of these examples and more are defined in more detail at our repo, which is at github.com/Twitter/Sekhmet, SEKHMET. So we're looking for feedback from the community to the spec before we fully publicly open source this. As an observability team, you are in a special position to differentiate based on what your company needs. Find where those gaps are to make your users' lives better. Our history starts earlier than many at Twitter. Our entire stack was a differentiator when we started out. Now, one of the key differentiators and primary reasons we invest in solutions at Twitter is scale. Recognize that not a single issue I mentioned was a problem of scaling servers. It was a problem of scaling and enabling people. Sharing our pain through the process of our migration and adjustments we're making is done to try to improve our lives and possibly yours. We're not saying that the steps we have taken or are taking are the right ones for you. We feel they're the right ones for us. In some cases, you may have to make mistakes to gain deeper insights. I encourage you all to do your best, but expect to make mistakes. By making those mistakes, you'll learn volumes. I'm hoping that you'll take away from this the fact that we share the knowledge so that you can make new and different mistakes and that you might have a chance at a better future. Now it's up to you to make that future real. Thank you.
Thank you. I did such a good job pushing the button. So we've got one more thing, really quick. If I can figure out, oh yeah, I closed Slack. I might need that. Okay, there we go. Oh hey. They really hated it. Where's George? George along? George works for Slack, so I'm just saying. Notice he didn't raise his hand. Hi, Ian.
Hey,
You want to turn your video on?
is it not on?
It is not on. You better restart your Slack client.
Let me try this again.
Okay. I swear this worked earlier.
Am I there now?
You are. You look great. How you doing?
I'm great. How's everybody doing?
Pretty well. Can we get a loud applause, maybe?
Thank you.
It was pretty good. It was all right. So I figured, why not, right? How many conferences get an opportunity to do sort of something like this? Does anybody have any questions for Ian? Please have questions for Ian. I mean, seriously, come on. How about the name? Where'd the name come from?
The name is in the repo.
Well, yeah, I kind of assumed the name was in the repo, but
the description of the name is included in the repo. So Sekhmet is an Egyptian goddess of healing and fire. There's more details there, but that's where the name came from. We were hoping to deal with systems that were on fire, and the fact that we want to help heal them. It made some sense.
So what are your general thoughts on video buffering? Just kidding, I'm kidding. I had one other question for you. Oh yeah, so what happened with the demo there? So in Ian's defense, he actually did the whole demo, and I was like, stupid. And no, he did a great job. He did all the edits and encoded it and everything. He got it to me this morning, and I can't thank you enough, Ian. I really appreciate all the effort you put into this. It was great to have you here in your own special way, and hopefully we'll have you back in person next year.
I sure hope so.
All right. Thanks, Ian. Have a good one.
Thanks. You too.